thank you so much for joining. And it's great to see you all because it's a community session. We'll not be able to allow you to unmute and ask questions, but feel free to use the chat. I'll try to spend time answering the questions, right? And yes, I will not approve any fireflies or otters to take notes. I'll probably throw them out of the class. I don't think they make sense. So yeah, thank you so much for joining. It's great to see you all. I am Arun Nandewal. I am a senior product manager at Microsoft. We'll be covering RAG today. So I'm glad that you are investing your time and effort over this weekend and next to upskill yourself. It's a fantastic opportunity in today's world to see the next version of AI product leaders come here and launch. And thank you so much, Product Space team, for all the good work that you are doing in terms of democratizing this content and learning via this platform, right? So couple of requests from no, you don't need any knowledge of Python per se in this session. And yes, how do you access class one and recording? Probably Product Space team can help you with that. From the Product Space team, if you can take care of people's Q&A in the chat, one, and two, if new folks are joining in, if you can let them into the class so that I can focus on the delivery. I'll quickly get started with that in terms of RAG. Let me just share my screen so that and we'll see how long we can go in the next 1.5 hours, because we have only 1.5 hours plus we have a lot of good content to cover. So hopefully we'll be able to do justice to this. I'll just share my screen. Let me know when you're able to see it. Okay, great. If we get time at the end, I'll try to take one or two people questions in person as well, but only for those who have their cameras on through and through the session. So that is one direct incentive for me to keep people on their cameras. That's great. Oh, a lot of cameras are now coming on, which is fantastic. This always works. So I'll keep a lookout on people whose cameras are on, and in the end, if we have some time to take some direct Q&A, that'll be awesome. Neha, I see you as well. So for the cohort members, if you are a cohort member of Product Space in the past or in the current cohorts, we'll do a dedicated session for you on RAG. We'll cover this session and more, plus we'll build a hands-on agent as well of RAG with zero code and no code. So it might, plus we'll do your Q&A as well. So you can feel free to drop off, probably watch the fantastic match, which is going between India, South Africa, the women's final. For cohort members, we have this session planned out. So Neha, Soni, if any one of you is from the cohort, I would say don't spend your time in this 1.5 hour session, because one, the depth is maybe a 101 and 200, and two, the hands-on part where we actually build a RAG agent, we will handhold you with doing that today, because it is a community session. We will not get time to handhold everyone, and we'll just go ahead and do that. So feel free to drop and do something better, or the one that we learned about Hugging Face today, probably you can spend some time doing hands-on on that. Yes, Shivam. So for the old cohort as well, from C1 to C7, we have built latest content around RAG. So we will do a community session for our previous cohort members. We'll invite C1 to C7, all of them. Okay. With that, let's get started. So this is how the agenda of the class looks like. And we'll probably talk about why do we need RAG, what are the limitation of LLM models, right? And when we think about RAG, why is this such an industry relevant thing? Why do all organizations want to set up their own RAGs? That's part one. Second is, if you are learning RAG, what are the major concepts around a RAG LLM model that you would need to know on? How do you build your own RAG, right? Third is, if you have to allow role-based access around a RAG, who sees what of my data, how do you make that happen? So how RAG works, if you are doing a DIY, which is do it yourself, or if you are creating your own RAG from scratch, right? What are the things that you need to know? Probably what are the expectations from a RAG PM as well? We'll try to cover that. And then application of RAG for product managers. I think in the first 1.5 hour that we have today, we'll be only able to get till that. And then there is also metrics that we have for RAG. What are the metrics? How do you check efficiency, accuracy, um, relevance of RAG, citation criteria for RAG? That is one more thing that we'll dwell into. And that's the agenda of the class. Because it is a community session, after probably like 30 minutes of delivery, the request is from, again, the product space team. Just look at the questions. Wherever there is um, fluff questions or irrelevant questions, don't bring them to me. If there are questions where there are maximum number of thumbs up and most of the people want them to be answered, feel free to bring that questions. After like 30 to 40 minutes of delivery, I'll take time to answer those questions. So after every part of this delivery, we'll take a pause and we'll take that up. Yeah, thanks for the product space team to give that acknowledgement. So let's start by foundationally understanding what are the limitations of RAG, or what are the limitations of, sorry, LLMs. Why do we even need RAGs, right? So I will probably ask the Janta that is out there. It's a community session. What do you think are some of the limitations of these LLM models? Let's just brainstorm and see all the LLM models that we have: GPT-5, Claude 3.5, Gemini 2.5 Pro. What are some of the limitations of these LLMs that you see today? One of them is hallucination. Fantastic, Bhuvan Sayan. I don't know if you are giving some scholarship or not to these students. If you have, do take a note of these names. Trained on specific data only. So they have, um, I'm just reading, Prashant Thakur says hallucination, cannot find context. Okay, one is there is hallucination. They cannot tell everything with high level of precision. Second, I read from Priyanka Hundelkar, it's trained on specific data. So it's trained on certain type of data. If I have to ask contextually relevant questions about me, my organization, and if I want latest data, maybe they'll not be able to get it. Fantastic. Yes, Rishita Shane says that there is an inherent bias that might be there. So if there, it's very simple concept of garbage in and garbage out, right? So if there is garbage which is trained on these data sets, it's garbage out as well. So that's another limitation. Fantastic, Neeraj. Amazing point, Neeraj Patil. If you are noting names, just reading it out. It's the context window. So they have a very specific context window where they can only store so much of information. If I want to give them like 5 or 6 hour long video, it will not be able to get the entire context. And then there is knowledge cutoff again from Biswajit Mondal. I don't know if Biswajit, it's a common name, or we had you in our one of our cohorts as well. Yep. So that those are the right, and I think it's the same thing which is repeated by most of the other folks as well. Those are the kind of right limitations. Now, knowing that these are the limitations, what is the best way to solve for them? Right? One of the right ways to solve them is RAG. How does that work? Let's talk about this. So what do your LLMs do well is on the left hand side, and what do the LLMs don't do well is on the right hand side. Let's just read it from as you all gave your answers, right? First, it is trained on massive data. And if I ask any questions, it'll probably give you the right answers on what it is trained on. There is language fluency. So if you ask it to give you it in a witty tone, or in a formal tone, or in a crisp manner, or in a bullet point format, or in a table format, the LLMs are powered enough that they can do this for you, right? They are really good with pattern recognition over time. So if you use your LLM model as a product manager over, say, couple of months, it will understand how you use the LLM model and what type of responses do you like, and it will start responding to you in a similar manner. And fifth, it is good with creativity. We have all created Ghibli images. We have all try at story writing and doing our assignments if some of you are students. So it can give creative new ideas. This is what LLM models are good at, right? Now building on the answers that you gave on the right hand side, right? Where do they fall short? First of all, the biggest problem till they were scraping real-time internet data was, at least in 2023 till October, if you asked it, give me this information, they would say, I am only trained till September 2020, right? And I cannot give you the latest information. How many of you can just give a thumbs up? How many of you have experienced that? Right. Yeah. So the first point is, even the models which are released today, let's just look at one of them. Um, let's go to LLM stats. Let's look at the most recent model that we have. Let's compare. So we have GPT-5, and on Gemini, let's add Gemini 2.5. Oh, it's Gemini 2.5 Pro. My bad. It's not Flash. Flash came in earlier. So GPT-5 and Gemini 2.5 Pro. If you compare them and if you look at their cutoff dates, so these both have a cutoff date. GPT, in fact, has a cutoff date which is 1 year old. GPT-5 it stopped the knowledge cutoff on September 2024, right? And Gemini stopped at the start of the year. That's also almost 10 months old for you. So they have a clear knowledge cutoff date, right? Uh, and this kind of stops us from getting the most recent data. Most of you told about hallucination. These are probabilistic systems which give probability as an output, and that's why they are probably not giving you exact contextual information that you can really use. Third is inefficiency. They, until unless you tell them, give me a very concise, precise 2-line, 3-line answer, they can keep on generating content and they will keep on burning tokens because their monetization model only works on tokens. And tokens, you have to understand this very clearly. This does not only work on the output. Tokens are also a limitation on your input. So if you give large tokens as input, like if you're attaching large files or if you're attaching very large prompts, the money again gets burned there, right? You are ending up burning tokens on your input also. And then there are data boundaries. One of the biggest concerns for professionals who are working in organizations is, hey, garbage in, garbage out. Okay, I can deal with that. But what if my company's data gets leaked? It goes to the LLM model and then the model is trained on that. Next, if I am working as a product manager at Zomato, my data is leaked and tomorrow it is available to Swiggy. What do I do? So there are strict guardrails around data privacy, data boundary, where most of the organizations either take the enterprise licenses of these products or they clearly say that will not allow this in our companies. Most of you who are working, and you can probably again show a thumbs up if you face these limitations in your company, saying don't use any of these AI tools or use only the enterprise licenses because there is chance of our data getting leaked, right? So these are standard problems that all of us face, and to solve for all of these, it's important to understand across the life cycle of input to processing to output, right? How exactly does it work? Let's look at this from an example perspective. So when I give a prompt, I'm giving you the input. Users have to manually give information, always saying that, hey, you have to work or you have to think like a product manager, or you have to give me advice. Every instruction every time needs to be given in a prompt, right? Second, you have to update your personal information always, either as a PDF or as a Excel dump, and that again counts for token. So we as users end up spending more time doing prompt engineering, crafting better prompts rather than relying on these models, right? This is as good as saying I have a doctor. I will not trust the doctor to do his or her job. Rather, my job is to explain them clearly what my problem is. And I will spend 2 hours explaining to them, and probably they'll spend just 2 minutes in processing and saying, this is the problem that you have. Right? So there are limitations where we as users end up spending time providing the latest information and doing prompt engineering. Model can also forget earlier information. How many of you have created like 7 conversations? By the time you reach to the 8th conversation, you ask a chat GPT, hey, I asked you this go-to-market strategy in the first conversation. Do you remember? And it says, I don't remember. How many of you have faced those issues, right? So again, this is something which we don't want these models to, or these LLM applications to really struggle with. We would expect that they can keep memory of context of my data. Plus, even if they're giving us inconsistent answer, one of the biggest need or professional demand is, if you are not sure, tell me that I am not sure, or tell me where did you get this information from, rather than just throwing up things in the air, right? Wherever you are not able to quote your resource, or wherever you are making things up, at least give me a citation. Tell me where did you get this information from. And these models don't do that. They generate plausible incorrect facts, and there is no way for you to, and this is called the black box problem with LLMs as well, right? The black box problem is, I ask you to do market research for launching cold coffee in Indore. You give me some number, I take that and I try to raise money, but I don't know where did you get that number from, or what assumptions did you make, right? So that is another problem with this. And when finally they generate the output, first thing is, we as end users, we are supposed to validate the output. When we present it to leadership, or when we use it in our work, we are expected to make sure that these answers are right. Similarly, if there are large prompts or multi-iteration prompts, you are expected to improve your prompt with every new model. These models are doing nothing for us. So across the user journey of an LLM applications, these are the points. And why this is important is, if you're a PM, or if you're someone who's looking to use RAG, if asked in your organization, or if you're applying for a job, if asked, why did you even use RAG? You have to explain this from an LLM cycle. Like what a RAG solves during writing a prompt, during processing, and post output. A RAG solves for all three of these, right? Let's look at how exactly that happens. So retrieval augmented generation, before we talk about how exactly this works, let me show you an example, and I'll zoom this in. This is what was happening till December or November 2023. I would ask it where, and this is a snapshot from a Google's paper, so you can refer that as and when the product space team sends you these notes. Where is the next show of Arijit Singh happening, right? It would tell you, I do not have access to the real-time information, including concerts and schedules, to find out where these songs, show, or concert is happening. These are the websites that you can go for, right? With RAG, what you can do is, you can augment your prompt. Remember, there are three words, which is retrieval, augmented, generation. So augment, retrieve your information, latest information, augment that with your prompt, and then ask the LLM model to generate your response. When we are augmenting the information with prompt, we are also making sure that this information is not used by the LLM model to train itself on. And how does that happen? Because we are anyways adding information in the prompt, you would say, hey, doesn't this go to the LLM model? It gets trained. We will try to answer that, right? But now if I ask when and where is the Taylor Swift next concert, I am also giving this augmented information to it from my real-time database. And this database might be from a Make My Trip, or it might be from a Book My Show, wherever these shows are listed. And then it is asked, the LLM is asked to generate the response, right? So Taylor Swift's next concert is on October 18th. And these are the shows, and these are what you can book, and these are the websites from where I got the information. So it's not just telling you where the show is, it's also telling you where did this get its information from, right? This is what RAG is. And if you have to give a theoretical definition, it is retrieval augmented generation, retrieval augmented generation. Remember all the three keywords: retrieve your latest information, augment that with your prompt, and then do the generation with your LLM model. It is used to incorporate your company, domain, industry, external sources as an information source to the LLM responses itself, right? One way of doing RAG or existing mechanism is fine-tuning your LLM models with more specific data. But the problem with fine-tuning, and this is one very common question that gets asked, why can't I just fine-tune my LLM model with all the RAG information? Your RAG information is ever evolving. it is always real time. So RAG enables real time updated information if it comes. Think of it like this. If you had to fine tune, you'll spend, if not days, at least couple of days or hours. And in the meanwhile, new information comes in. How do you make sure that it is having the right information, right? So RAG is something which acts as a live database for you to provide that information to your LLM every time a user prompts. Now, how RAG works and makes LLM smarter or more reliable. Earlier, the flow that we were talking about on the second slide, which was input, LLM processing and output, was doing this, which is relies only on pre-trained data. There is limited context window. It's prone to hallucination, and there is high input and token cost. All of this, all these problems you called out. What happens with RAG? First and foremost, and again, this is more of a theoretical or an internet sort of an answer, which is helpful in interviews, especially. Why do you need to use RAG? One is it helps you with dynamic real-time database. First, so it's giving you latest information that can be passed in your prompt. Second, it makes your answers accurate because LLMs can now tell exactly where did they get their information from. They will not hallucinate. They will tell you, I got this information from this page number on this book or this website, this particular page, this widget, right? They are efficient because they help you reduce the token size and they make your prompts better. We'll talk about that, how that works. And then it is trusted because you as users, if you think any of the response that these LLM models are giving is probably hallucinated or is not correct, you can always go back, question your foundational answer and ask it, where did you get the information from? So your source of truth would always be there, right? Now, RAG by itself is not like anything in generative AI. It's not perfect. It's very important before you get all excited and start thinking about RAG applications and start building your applications around it. It's very, very important that you understand that RAG itself can have its own limitation. First limitation is garbage in and garbage out, which all of you might know. So if you create a RAG database which has a lot of nonsensical information, then the output that you would get is also nonsensical. One of the standard cases of this we have seen in garbage in, garbage out was Grok 4. Grok 4, when it was trained on Hindi languages, was somehow trained on cuss words and bad words. And whenever someone talked or spoke or interacted with it in natural Indian language of Hindi, it also kind of gave it some slurs that the user would never go back to it. So if you upload bad data without looking at what exactly your data is, then it will also probably give you bad output, right? That's the first part of it. Second, as PMs, it's not very simple just to say, when I create a RAG, I will dump my PDFs, I'll dump my images, I'll dump my videos, I'll dump my Excel and SQL databases, Cosmos databases somewhere, and everything will be automatically taken care of. RAG comes with its own learning around indexing and chunking. Chunking is how do you split your text into tokens? Because see, at the end of the day, you just don't want, if you are wanting to create a RAG application where you are okay to give away all your data for free, the best way to do it is use custom GPTs. Custom GPTs, you can give a system prompt and you can upload all your files. Next time you ask GPT, that custom GPT to answer, it will do chunking indexing on its own and it will give you relevant information from those PDFs. But your data is no more protected. You have voluntarily in custom GPT given away all your data. So if you are thinking you're creating a custom GPT and you will upload all your files without any guardrails of enterprise role-based access, it's gone. But if you want to create a RAG where when you upload files, how the file is broken down into words, how those words are broken into tokens and those tokens are converted to embeddings, all of that as product managers and as data scientists, you need to understand that. That is first part. Second is indexing. So because your RAG can be either 10 files or it can be 10,000 files. Now, indexing is when I ask a question to a RAG, where should it go and look for the answer? So think of yourself as a product manager in Amazon, right? And you are creating this RAG for all the customer queries. If I just dump all the customer queries and the possible responses, you will have like millions of queries. There is no way for RAG to identify where should it look at. Or what you can do is you can create an indexing pattern where you say, okay, this probably path stores all the related queries to Amazon Pay or payment related. This is related to orders. This is related to user profile. This is related to addresses. So you have labeled your data or you have categorized your data. Within payments, you have categorized it further or you have created more distributed structure around. Payments can be refunds. It can be around Amazon Pay recharge. It can be UPI transactions, or it can be something where the user is having credits or ICICI credit card refunds. This labeling categorization can enable the RAG to do faster processing and give you faster data. If you don't care about that, and if you just say, okay, let's just create a vector database, dump all the files in this, don't worry about different formats, Excel, PDF, Cosmos, MongoDB, SQL, SharePoint. Keep the data, let the vector database figure it out for itself. You will end up, you'll write a query to process that from a RAG and to give you an output. Earlier, your LLM might would have been taking like 5 minutes or 7 minutes, and now it will start taking like seven, if not 5 minutes, then probably 3 minutes, 4 minutes per query. Think of your user sitting there and waiting for 3 to 4 minutes just to get the output because you have not implemented your RAG correctly. And tokenization is also very important. Someone might say, I want very, very highly accurate data. I am creating this UPSC, UPSC's Union Public Service Exam for bureaucracy in India. I want to create a UPSC RAG. I will have 10 books as my resources. Every word I'll create as a token because I want high level of accuracy, right? So you have created very small tokens and you have created very small chunks. That means high precision, but higher latency as well. And the other person might say, okay, I don't want it to take a lot of time. I will make one chapter as one chunk. So that is low latency, but low accuracy. So you have to also identify the right mix of how much chunking is right chunking and how much indexing is right indexing. And we'll cover all those concepts today while we go along. Third one is retrieval precision. It's not just about retrieving the content from your RAG, but also giving the right citation. If you have ever traveled in countryside, there can be two people. One sort of people can tell you go straight, then left, and third right, or someone can tell you, I don't know, maybe it is somewhere in this direction. You can go and ask the right person. So your RAG can actually give you precision. Let's continue to use this UPSC book example itself. It can tell you this book, this chapter, this paragraph, and this line number. So you exactly know where did it pick the information from. Or it can just generally say you one of the books out of these four books, right? So how much is your retrieval precision? The information that it has fetched, can it give you metrics which are to the last grain accurate or not, right? So these are some of the limitations and learnings that you need to have, and we'll try to get to as much as of these as we can as we go along, right? So this is the theoretical part of it. There are latency and cost and security governance. When we talk of latency, I've already told you more tokens, more domain data, more latency, and more the response time. One very important thing that people don't recognize is security and governance around RAG. So I might be having, because I only see three folks who are on camera throughout, which is Vishal Rai, Nikhil, Nil K, and Abhilash, right? These are three folks who are working with me in Amazon as product managers. Now, Abhilash is someone who's from the HR team. I and Vishal are product managers. And Neil K is someone who's wanting to join, right? So we have an internal RAG which stores all the employee data, right? In all that employee data, before joining, Neil K is doing salary negotiations with Abhilash, and he wants to see how much internal product managers or senior product managers are paid. Should Neil K get access to that information before he has joined the organization? Just put this in the chat if you think no, right? How do I control depending on user provisioning that RAG does not give information to Neil K? Now, performance cycle has happened. We have all gone through performance reviews. Abhilash wants to see my data, and Vishal also wants to see my data. Just type it in the chat. Who should be able to see my data? Abhilash or Vishal, or both of them? Both of them are part of organization. Abhilash is the HR and Vishal is the senior product manager who's my peer. Who should be able to see my data? Abhilash only, right? Fantastic. I'm great that you are at least having your foundational concepts clear. When you implement a RAG, how do you implement this role-based access? How do you ensure that the person with the right credentials can only look at that data even if they are internal to the organization? That's a very important criteria when you implement overall end-to-end RAG that you need to. Yes, RBAC and IM. RBAC is role-based access control. How do you implement that on a RAG? We'll also try to cover those. This was the first part of trying to get you to a elementary level of understanding of what RAG is, what are the essential principles of RAG, and what can go wrong in RAG. If you are with me so far and if you have not slept and if I'm going at a right pace because I want to cover as much as we can, give a thumbs up. Awesome. Let's keep going. Now, how is it? How do we use it? What is it and how it works? First of all, try to understand the 4 concepts that you need to implement when you implement a RAG in your organization, right? There are store. Generally, when people think of RAG, they only think of one thing. And that one thing is vector database that I'll need to store my data on. No, you need to create 4 things when you create a RAG. First one is your vector database where you'll store all your information. Second is your retriever. Retriever is your system instruction telling how should I retrieve the data. It should not happen ki this is the database, go and figure it out. It should not look like this is a pile of crap, go and figure it out where you need to look for the right information, right? You have to give system clear instruction where the retrieving should happen so that it is able to retrieve and then pass it to this. So first one is document store, second is retriever, then the third one is generation, how the system should generate, what is the system instruction to generate the model. It should not happen that 90% weightage is only given to whatever is retrieved. LLM will not do anything. You tell LLM only retrieve the only generate the content from whatever you have retrieved. Don't apply your own brain. So you have to also give the generation system instruction. Keep a mix of what you retrieved versus what you did not. Use your own brain to make reasoning on top of that. Is it 80-20 retrieve and innovate, or is it 80-20 retrieve and generate, or is it 100% just retrieve? If you are having 100% just retrieve, why do you even need a RAG? Right? You can just have a database access query resolution where you write the query and get the data. So when you implement a RAG, the 4 things that you need to work for is retriever engine, which will make sure that you're retrieving the most relevant chunks. Second is generating, giving the system context, how it needs to generate after fetching the data. Third is your knowledge base. The fourth one, which is not mentioned in this because it happens after the generation happens, is metric or telemetry. After generating, it should be able to give you the citation. Where did it get the data from and where did it refer this data from? So in an exhaustive end-to-end RAG, these are the 4 things that you as a either as a data scientist or a program designer needs to take care of. So RAG combines retrieval, generation, so that the model can use external information to give accurate and correct answers. With me so far? Make sense? Awesome. Let's look at each of them. How do these works? So first one is the system prompt. So I would probably say something like this. You are an AI assistant that answers questions using retrieval context from the company's document store. Always search for relevant documents before responding and include citations when possible. This instruction we are giving to our generator, which is sitting here, which is your system prompt. You are telling your model, which is either GPT-5 or Gemini 2.5 Pro, that listen to me, you have to make an attempt to first retrieve the document, give the citation for that, and then generate the content. So this is called your system instruction or your system prompt. That's the first component. Second component is I will create a retrieval process where I will decide, one, how will I do chunking? How will I break my entire context? You might be uploading a SharePoint, you might be uploading an Excel, you might be uploading a data lake like a data warehouse, or you might be uploading from just manually taking user input from an Excel. All of those have to be converted to embeddings, broken down into smaller chunks, stored in a vector database. And once they are stored in a vector database, the retrieval should also tell you which chunks are you expected to retrieve. Because see, once you have broken it down, there might be hundreds and thousands of chunks that might be there in your vector database. Which chunks to retrieve and how to retrieve them. And this is very simply saying there are three ways of retrieval, right? One is I tell Vishal, go and find the first five poor people that you see who might need help, and we will do some charity to them. That is one way of me telling Vishal, retrieval should be first five people that you see who need help. Other type of retrieval will be spend your entire day, find the most five people who really need help, and we will give them large amount of charity. Which one will take more time, the first one or the second one? Second one, right? But which will give us more accurate or relevant results? Second one, right? This is latency versus cost, which you need to clearly define. How do you identify the top K results and which are the top K results? Finally, when you have generated your response, in that response generated, do you give citations, and how do you give citation? How is the response grounded? Because end of the day, the problem that we are trying to solve is this: LLMs can generate hallucinations. I don't want that to happen, right? So these are the components which need to be defined in a RAG. If someone asks you this question of step by step, explain me 1, 2, 3, 4, 5, how or what happens in how internet works. Similarly, if someone asks you 1, 2, 3, 4, 5, what happens in a RAG? Let's look at that 1, 2, 3, 4, 5, 6, what you need to do. First, the user will give a prompt. I want you to solve this problem for me. Again, the same example of Amazon chatbot. I am as a user asking this order retrieval, right? Tell me the status of this order. Where will this come from? So that is the prompt that is given by user. I will make a query out of that. I will make a query saying that I need to get details of order number, this. So in table order details, search this order ID and search the details of when this order will be tracked. So that's your step one. Prompt converted to query. This query will go to your data, search relevant the data, whichever is there. It goes to the search data sources. It will search what is the order, what state is it in, what is the expected delivery time, right? Step 3 is once you have extracted this relevant information, pass this to the prompt, right? And step 4 is prompt plus enhanced context that you have gotten from your query. So prompt, query, enhanced context. All of this will be put through a system instruction that we defined earlier, which was step 1. How to generate this goes to LLM model. It will generate a response, goes here, and your user is able to access it. So if you want to add another step in between, your step 5 would be a system instruction. Step 6 would be context information, system instruction combined together, sends out the output. This is how it works foundationally, right? If I have to break down the internal mechanics of what we will be building today or what we'll be seeing working hands-on, right, is this internal thing, what is happening here? What are the things that a PM or a product manager needs to create or be hands-on on? When we create our own agents as part of this learning, or when I have to show you the components, what are the things that I would want to probably show to you, right? User and question, the prompt that we have is visible to even today also. What are the components which are not visible to us inside a RAG is first, what is the embedding model? Embedding model is when the user gives the prompt, how are those words converted into tokens and how are they stored in the vector databases and what type of search is applied. Step 1, step 2, step 3. Just repeating because this is very important. What embedding model you are using? How is it being broken down to word tokens? How are those tokens converted to embeddings? Embeddings are machine understandable format. Second, how are they stored in the vector database? Right? And third is after they are converted and stored in a vector database, how are they retrieved, or what is the search algorithm which is applied to get these tokens mapped to whatever I have stored in my RAG database and then the tokens which are extracted and given out, right? So these 5 components, your vector database, your embedding model, your vector store, and similarity search, plus the output with the right citations, is what we build in a RAG. 1, 2, 3, 4, 5. Most of the people who use out of box RAG capability only focus on the vector database. कि एक database लगा देंगे, उसमें सब कुछ dump कर देंगे, we'll create one database, we'll dump everything inside that, and it will get generated. No. We have to also figure out the embedding, the tokenization, the search, retrieval, and then once the tokens are given out, the similar pages that are given out, how do I pass that to my LLM model, right? So this is entirely your theory. Now we will start seeing hands-on to this. I'll just take 2 minutes. Team product space, what are the questions that we have in the chat which have most, we have delivered like for 40 minutes of content. Let's take some Q&A and then I can move forward. Akshay or Imanshu, if you have questions, can you?
Arun, we have one question when you are explaining vector DB. Question asked by Shruti. So does the vector DB has the updated data source library like resources, web page, blog, industry report?
Right. So vector database supports all of these, but you as a PM have to take care of embeddings and converting them to tokens. You have to implement a chunking mechanism, step 1. Then you have to, and I will walk you through when you create your own RAG. This is your DIY, do it yourself RAG. You do first, Shruti, you create a collection of all the data sources that you want. Then you parse all these documents in the standard format, because vector databases by themselves don't do the storage part for you. You break them down into smaller chunks called tokens, make them into embeddings which can be stored in the vector database. This is the only part which is done by vector DBs. They only help you with storage. The first 4, collecting data sources, parsing them, chunking them, and converting them to embeddings, is all done before, and this is called your data preparation. So all of that has to be done prior to storing it. So vector databases store embeddings and help you with retrieval of it, but all these data sources collating, parsing, chunking, and then converting them to embeddings is something that you will need to do. I hope that answers your question, Shruti. Any other question from anyone, Himanshu?
No.
Nothing? Are we good?
Yeah.
Awesome. I'm just seeing.
We have a question from Monica. How can
Yeah.
we create a RAG with vector DB with client sensitive data?
Yes, that's what we are trying to build. And that is what we'll try to teach as well. Like the idea here is role-based access control RAG, which is protected and stored, which can, the idea of even going for RAG and why organizations are investing so heavily is they want to protect their data. They also want to use LLM capabilities, but they also want to protect their data. Okay. I'm just seeing how can we create RAG with vector DB with client. I've already answered that. You don't need to, Krishna Prasad, you don't need to update your vector database. The idea is once it is created and the RAG agent that will also try to build hands-on will be triggered automatically. And those triggers can be multiple. The 3 triggers that we'll be using with Google Drive is, if there is a new document added to my Google Drive, update your database. If the document existing in the Google Drive is changed, update your database. If a document is deleted, so update, delete, add. If any of these things happen in your database, automatically this entire process of chunking, tokenization, embedding should happen with the latest, and your database should be always up to date. If you end up doing it manually with every trigger, it's not going to scale. Like you need to keep sit and seeing anytime that a new data comes in, right? Okay. I've already covered what security issues do you have. Difference between query and prompt. Prompt is what the user asks. Query is what you need to pass to your database to understand what exactly needs to be retrieved. RAG is localized, knowledge graphs are more pervasive. So who's this? Pratik, I think knowledge graphs are more thin spread and they don't work on multi-formatted data where chunking, tokenization, and storage are in a RAG, you can control that. In a knowledge graph, those are more standardized with one format allowed only. No, RAG can take multiple type of documents. You need to create it in a manner that your chunking, embedding, and tokenization is done consistently. Okay, I've answered enough questions. Let's get going with an actual hands-on, and I will share a link of this right after this. So let's keep it here. You can also play around with this playground. First, let's try to see how it works at a very, very high level. And then we'll also kind of do a deeper dive. I have this user query. Let's just select 100K. A cute brown frog, a cute brown dog jumps around the tree. I want it to do something. What I want to do is I've given the system instruction here. You are an expert in prompt engineering, text to image generative models. You are helping a user improve their prompts. The user prompt is this. The user will give you a small prompt like this. This is the user prompt. You have access to example prompts. So it has access to, it's still loading, maybe 65, 70, 100K, 100,000 documents, all filled with different type of prompts, right? You refer to the user prompt. You have access to the example prompts in this context. Your answer should be based on example documents which are uploaded here. Make the user prompts more interesting and effective. Cite examples to explain your improvement, right? So what it is saying, user will give you a prompt, very simple prompt. This prompt, yes, this is the playground. Yep. So we have a RAG where we have stored 100,000. It's still loading those 100,000 documents, and all of those documents have different prompts as examples which it can refer. It has used a diffusion DB, right? I am saying it, use this user prompt, fetch data from this RAG, right? And improve this prompt so that I can use to create an image. So there are two inputs, one input which is the user prompt which will come from here, and the context which it will retrieve from the DB, right? Let's just run this. I'll just hit run. It's using GPT 3.5, right? Right now, I have not run the RAG. It has just, I can change the model also if you want. You can play around with the GPT-4, Gemini Pro, whatever you want, right? Just play around with that. This is the search. I have told give me the top 5 parameters. And let's now run this query. So it has originally just used the user query, and let's click run. Let's see what happens. So it took the user context as is. Now it is running the RAG. From the RAG, it has picked 5 top K results that it could fetch, right? And the query is document similar to this user query. It has given me a hairy dog with a big parachute jumping from a cliff, a flying tree with a chipmunk on top, a cute pet rat, fluffy mouse. If you see, it has taken these top 5 results from the RAG. The probability of fitting or the top 5 are basis this probability match. It has 0.87, 0.86, 0.865. My original prompt is added with this context, and it has given me one final prompt which says a playful brown puppy frolics under a shadow of towering oak tree. It took this context, this did, and then the output is this. And the reason that it is giving me is by incorporating more descriptive language and adding elements of playfulness and nature, the revised prompt becomes more engaging and vivid. This is similar to the prompt, a happy dog in this context, which uses emotive language. So my system instruction was get the user prompt, get the context, and give the example, given explanations why you did this. So it has also given me an explanation. Rather than using just 5 tokens, if I were to ask it, use the top 10 tokens that you can search for. Let's try to do that. I will just say do the top 10, right? Now let's hit run and let's change this prompt. A small tree looking up to the sky for hope. Let's run this. Now a tree open its eyes, a tree with rainbow leaves. It has taken all these 10 rather than taking 5. So how many results or how many tokens do I want to fetch? Right? This also is decided here. It gives you those tokens, it gives you that context. And after the context is given, it generates the prompt for you. A small tree reaching towards the heavens, its branches stretching out in search of hope and light. Much better than what I had written. This is just at a very high level what we see. This does not show you how the chunking was done, how this data was stored, how this data was retrieved. So none of that is clear. We just know I gave it a prompt, it was able to fetch from the RAG, and it was able to get you the output which is contextual to your RAG, right? Let's try to create our own RAG which is more contextual to what we are trying to do. Let me close this out. Let's actually see what's happening in the match. Let's go and look at this. Okay, India is in a good position. We just lost 3 wickets, and this is the live commentary for the finals which is going on between Indian women team and the South African women team. This is the second visualization tool which will actually help you understand this RAG concept much better with each component in more detail, right? Let's delete this. Let me copy the commentary of the latest one from here. Let's just copy some random data. Okay, I'll only copy till here. So let's look at this. Think of this, that this is the real data that I want to store in my RAG, right? First step that we spoke about is you have to break this down into chunks so that you can upload this in your vector database. Now, what I have told here is the chunk size is 500 after every 500 characters, right? You can read about here what is chunk. So if you just hover over this, maximum number of characters in each chunk, large chunks preserve more context but may exceed the token limits, and overlap sizes from the last chunk to the next one, how many words should overlap, right? There are separators, which is if you see a full stop or if you see a new line character or if you see a space, you can create a new chunk. So let's see this. So if you see this, this is one chunk. The color coding tells you how the chunking is done. And this is a very good visualization if you just want to see how you would upload a PDF and how would it get chunked, right? So I've uploaded this commentary here. This is the first step that is happening. It has created all these chunks. This is step one. You can decide your chunking algorithm. There are different split strategies. Cover this as part of the cohort. Will not be able to do it right now. Might derail will not be able to cover the content otherwise. So you can decide your chunk size, you can decide your chunking strategy, and you can also decide your overlap size. How does that happen? If you want to read more about this, you can read it here. Will not explain. But this is your first step where you upload, collate, and also answering Shruti's question, right? Your entirety of documents collated, chunked. Step one, clear, thumbs up. Then we'll go to the step two. Awesome. So this is chunking. Now let's look at second one, which is embedding. Embedding itself needs a model. In this case, we have used this Snowflake Arctic embedded model. You can also use ChatGPT's embedding model. You can also use the embedding model of GPT. Every LLM provider has its own embedding model, which helps you convert these chunks to embeddings, which you have to store. And if you see, each of these chunks that we had created earlier is converted to an embedding like this, which is a numerical representation. Let's look at the first one, which is, sorry, my bad. This is the embedding. And with this embedding, what are the most similar chunks? This chunk is similar to the next one because there is an overlap of 50 characters between this. This one is also similar to these other 5 chunks because there is a probably either there is similarity of name like loose or Shifali Verma, and it has done some logic to identify which are the similar chunks. But at this stage, what we are trying to understand is I pick my chunks, apply an embedding model, convert these to embeddings which the machine can understand. Then I apply a retrieval algorithm where I have to retrieve the right chunks, and retrieval would happen depending on the query that I ask, right? So let's just ask a query about Rodriguez. If you see, I'll just clean this up. I will ask Rodriguez. So these are all the chunks which are already created. The blue ones are the chunks which are already created and stored in your database. When I typed Rodriguez, it told me these are the 5 chunks which are closest to this matching word. Scored how, as I'm typing, you can see it is changing because depending on your query, the top chunks that need to be retrieved and returned by RAG are also changing. Scored how many runs. And now, depending on this query, these are the 5 chunks which are most relevant to give us the information, right? If I said Rodriguez scored how many on first ball, there are these 5 tokens which are most relevant. How exactly this works, how does tokenization happen, how does retrieval happen, what is the algorithm sitting behind it is slightly more detailed. We don't want to cover that because it's a session only for 1.5 hours and we can only do so much. But the concept that you need to clearly understand is first, chunking is done for the entire data that you store. Second, those chunks are converted using an LLM model. In this case, this is the Snowflake embedding model. These embeddings, depending on the query the user asks, is able to give you the chunks which are most closely associated with your query. Now, if I go ahead and generate my response, right? Let's look at this. I can also set my temperature and maximum tokens. So if I want a long response, I can give 1,000 tokens. If I just want a short response, I don't want to pay a lot of money to these LLM providers. These are hyperparameters. Again, some of you are into AI might know hyperparameters like top P, top K, temperature. Higher the temperature, more the innovative your model, lesser the temperature, more factual your model. So if I reduce this to very low level, which is 0.001, that means it is very accurate. I want it to only focus on accuracy of the result, no part of innovativeness. If you're able to find that in the RAG, give me the reply, otherwise not. Now let's click here and let's see the question and let's generate the response. And you see, it says, I don't know. The information provided does not mention the score of the first ball. So maybe we have not copied the information. How much runs did she score, right? Let's see this. Let's edit this matches. Rodriguez got out. Let's save changes and let's generate response. So yes, according to the context, Rodriguez got out on the 29th over 4th ball, bowled by Khaka. Let's just validate that. 29th over 4th ball. Yes, 29th over 4th ball. Khaka bowled it and she got out. This is able to give me this context. Tokens is 100. If I give it 1,000 tokens and then I ask it to generate response, it's still giving the same one, which is you can burn more tokens and get a larger response. Plus, in this playground, you'll not be able to see the citation. Which tokens did it actually refer? But if you go here, you'll be able to see. So Rodriguez got out. If you see, it has given 5 chunks, and these are its embeddings. And this is chunk 2, chunk 34, chunk 42, chunk 29, and chunk 37. These are the ones that it has given. If I ask you to cite where did it get this information for, if it is accurate, and if it is relevant, it should tell me that this is the chunk that it got for the information, right? And the system instructions that we have given is here. You are a helpful AI assistant. Use the following pieces of context to answer the user's question. If you don't know the answer, don't try to make up the answer. This is very important. Like in your system instruction, if you want your RAG to be really effective, it's always ideal that you tell that, hey, this is the context provided. If you are able to find one of the chunk, and if you are able to retrieve that chunk with high precision of more than 85-90%, give the answer. Otherwise, say, I don't know. That helps you from making hallucination or ungrounded facts, right? Now, let's go back. Quickly checking is working. The concepts of sourcing your data, converting them to chunks, to tokens, to embeddings, to vector storage, defining your top K, what you want to pull chunks, how those chunks are pulled out, and then once those chunks are pulled out, how do you give response and how do you give citation to those? Is that part clear? How does a RAG work, at least theoretically, end to end? Can you give a thumbs up in the chat or something? Do we? Awesome. Okay, great. I think Himanshu and product space team, one thing is clear, will not be able to cover the content. Maybe we'll need to do a follow-up of this session more, because I already see it's 7:07. So only till 7:30. So we'll need to do a follow-up session. But let's cover as much as we can, and let's try to actually give hands-on where students can build their RAG agents, right? So if you are a PM who's building companies organizational RAG, and this is an image from Google where Google Vertex has this functionality. There are 2 work streams that you would need to do, and in each of these work stream, this is the work that you'll need to do. The first work stream is preparing your data set. It's not just dump the data set in vector database like a pine cone, but it is also it's also about doing the first 4 bits. First is collating your data sources, collating where your data will come from, the endpoints. And Anirudh, your emoji is sleeping, I don't know. Sorry to wake you up. You're on your camera and your emoji just fell asleep. Okay, so collection is you get all your data sources, you define your web crawlers, you define your files, you define your databases. If it is pipelines, you define those. Second, you create a Python parser, or you create a JSON parser, or you create any type of parser where you would want to parse this data and create them into a similar format where there is consistency for you to do chunking. That's the second part, which we showed in our playground, which was here, which is chunking. And chunking algorithms are very standard with data scientists. You can just ask them which chunking algorithm we use and what are the type of data sources that we support. Then you do your chunking, and chunking is very important because very small chunks can increase latency but increases accuracy. Large chunks can lose context. Don't have very large chunks like 5-page PDF into one chunk. That does not work. Ideal rule is 500 to 750 characters of one chunk is good enough. It's optimized for cost, latency, and accuracy as well. So 500 to 750, or if you want to still increase it, 750 to 1000. And overlap in a 500 of 50 is good. It's always 1:10. If you create an overlap of, you create chunks of 500 and the overlap is 400, then ideally you are only creating chunks of 100. That does not make sense. So have a 500 creation chunk for context keeping, have a overlap of like 10, right? Then once you have done the chunking, use a LLM model. Ideally, if you are using for your RAG retrieval generation GPT, so use an embedding model also from GPT, right? If you are using a Gemini, use your embedding also from Gemini itself. Finally, then you store this in your vector database, which is whatever DynamoDB or Supabase or Pinecone, or you are using Google Vertex, whatever that storage is, it's mostly dedicated by the organization itself. So you pick that up and you store it there, right? Once your database is ready, you have to also set your triggers. Triggers as in when will this database update, right? If you update it on delete, update, and add file additions, that is good enough. But sometimes when you have databases like SQL or MongoDB, it is also good to have this refresh on join operations, because when you do joins or when you create more new views, that time also new data might come in. So if you create new views, you can have triggers on that also. This is called the pre-processing step to get your RAG ready. The second one is your runtime. When you have to runtime, that time you have to give one, what is the search pattern? Search pattern, is it greedy search? Is it top K search? It is the first match or the next best result search. There are different algorithms. We'll not be able to cover them today, but again, uh, I will share this guide in the resources. You can read it. I'm not trying to hard sell the code, but I'm just saying in the cohort we will do this. So if you're someone who's learning on your own and doing through these community sessions, go ahead and look at the appendix slide. It has resources how you can do the search algorithm better. And then generation, summarization and generation of your um, the triggers that I'm talking about, are they same as RDBMS? RDBMS does not have file additions and file deletions. Here we also talk about file additions, file deletions, endpoint additions, endpoint deletions. Like if I am adding a new page on Myntra.com/shoes, it's a new page that I've added to my website. Your DB will not be able to, relational database will not be able to get that answer. So this is DIY RAG. From an interview preparation also, this is a fantastic slide. So if you're thinking of applying for a RAG-based PM role, this will be the expectation and this is what you need to do. When we do hands-on building of N8N agent also, we will follow the same steps. Like we'll go through this one by one, right? First, so building your RAG DIY, first is ingest your data, collect all your resources, PDF, notions, email, internal websites, FAQ documents, tickets, relational databases, SQLs, pre-process it, break it down to chunks. As I told, 500 to 1000. This is not tokens, this is characters. Let me make this correct. Per chunk is good enough. And with overlap of 1:10. So for a chunk of 500 characters, use overlap of 50. Yeah. And then you convert them to embedding and indexing. I've given the name of some of the databases which you can use for storage, which is Pinecone, Chroma, and they also, then you apply your retrieval in the runtime. You give it a system instruction, you do generation, and on the output, one of the most important metric, and first I'll cover that, and then we'll see how much of the rest of the content we can cover, because on response generation, on when your answer is grounded or when the output is given, you should be able to also explain which chunk, and within that chunk, which line or which character was referenced to generate this out, right? So this is the overall journey of building your RAG. This you can consume on your own. What are the different types of RAG, like knowledge assistance? If you want to create a UPSC knowledge assistant, which helps you in retrieving content from books and helping customer support. If you have your company policy, like if you are an Amazon, and if you have a return policy, if you have a refund policy, we are doing something for Indigo at this point of time. So we are creating a customer support agent for Indigo. We are just dumping all their policies into the RAG, and the agent will be able to answer the queries for that. And then there is search and discovery enhancement. So if you are looking to improve the search recommendations of your product, and people use ChatGPT to search, hey, I want to buy shoes. Can you tell me where can I find shoes on Nike, Myntra, or whatever? Zero Dash started doing this for discovery of stocks and options and trades. So if you want to improve your search and discovery, content summarizations, you have very large meetings, you want to just dump it in the RAG and then it gives you action items. Data driven insights, your clickstream funnel data, analytics data comes into this funnel. You just want to extract and get insights out of that RAG. Domain specific chatbot. Someone was asking, I work in fintech domain. I want to get legal compliance, or this is very popular with Policy Bazaar and insurance tech companies, because there are so many heavy documents. If you are trying to sell something, you can just upload them in RAG, and then your user can come and ask, okay, I'm exploring uh, these three policies. In these three policies, what is the copay clause, right? And your RAG will be able to answer that with precision, right? So those are some other applications, and this is how you can build your custom RAGs. The easiest one to show in your portfolio, if you have not done that already, is custom GPT, right? If you don't want to do any of the data processing, indexing, chunking steps, just upload your files in custom GPT, create it, and it will be readily available to you. If you want to create real agent end to end without writing code, you can use NA10, and I kind of knew that we'll not be able to get through it. So this is what we end up creating or teaching in class, right? So this is the agent that we'll create. When we share this deck, we'll also share a hyperlink on a trained recording video where you can show how to, yes, you can also reuse it in real projects. We'll also teach you how to set this up with Langflow, because Langflow also allows you a layer of authorization and security, like where you can say who will have access to this data, right? So we'll walk through this, but let me show you something which is more important, where you will actually be able to apply this, the RAG metrics, right? So if you have uploaded file data sources, and think of the chunks which are created are file number, and within that file number, page numbers. Chunks are created within pages. So you have uploaded, say, 2 books or 3 books for UPSC, and okay, before we cover the metrics, are there any questions? It might be too much of content dump. So taking a pause, and if there are any questions which are relevant. I see there are a lot of questions, but Himanshu or anyone from product space, if there is anything which has a lot of thumbs up, can you take a minute or two? And Vishal and Neil K and Mohammed Diallo, because you were on camera throughout, I will definitely spend last 5 minutes in taking Q&A if you have any. So if you have anything, let me know.
I have a question from Kunal. So GenAI for EV creation has a high temperature setting or depend on the factual relevance of the content to be generated.
Yeah. So there can be use cases where you want to retrieve your context, but you also want to be innovative. An example of that is Amazon's recommendation engine. So I am looking for sneakers. I cannot just look at the word sneakers and give you only first 2 words that I see as sneakers. I want to be innovative and show you colorful sneakers, different brand of sneakers, different discounts on sneakers, right? So when you create a rag like that, you would want to have temperature high, but with retrieval. It should not give uh, sneakers from Myntra or Nike. It should give whatever is there in your database only, right? But innovativeness is required. Similarly, one more fantastic rag that I read as a case study was Spotify's um, playlist names. So when a user creates a playlist, they have their song selected. Now they want it to give a name like road trip uh, saga, or the memories of friendship, something like that. Now you would want that name to be innovative, plus also grounded in the songs that they have selected, right? So retrieval should be precision, but the name should be innovative. So your temperature can be high, but your should be grounded in what you have. It should not be randomly, like you've selected songs for breakup and it is saying romantic love for everyone. It should not do that, right? So RAG has to be high, plus the innovativeness should also be there. Any other question, Prashant or Himanshu or anyone from product space team?
One question come up a lot of time when you are explaining tokenization. How do we decide a chunking strategy? Like what will be the chunk size and like that?
So that's what I said. It's kind of theoretical. There are three standard chunking: fixed character, recursive, and parent-child character. You can read about them here, and you can also do a bit of research on your own. If we get into that depth, we'll not be able to cover the session today. So I did not go in that depth. Yeah, I'll come to you. Mohammed Diallo, Neil K, Anirudh, and Vishal K. I'll definitely come to all four of you in the last 5 minutes. Let's quickly cover some metrics as well, which at least I would love for you to cover on your own also. So when we implement a RAG, the foundational output that it should give should be able to point me to the exact chunk and the exact place where it got that information from, right? How does that happen? And this is called the metrics which are called for RAG are document precision, page precision, and sentence precision. So which website did it refer? In that which section did it refer? Within that section, which HTML element did it refer? Which database did it refer? Within that, which table did it refer? And within that, which row did it refer? It's called document, page, and paragraph precision, but it can be applied to any type of database. And generally, RAGs only stay at the top level where they define the document precision. They are not able to define page and paragraph precision. But when you build a comprehensive RAG, you should be able to do doc, page, and paragraph precision. Let's look at this as an example. Think of yourself who has uploaded multiple files, file number 1, file number 2, file number 10, maybe 50 files. And each file has different number of pages, like 5 pages, 10 pages, 23 pages, 24 pages. You have asked it a question, right? You have asked it a question and the answer, sits in two files, file number 1 and the page number is 3 and 6 and file number 2 in page number 23. So this is where your answer lies. The RAG retrieved some chunks and these are the chunks that it retrieved. Chunk number 32 came from page 32 of file 2, page 66 of file 10, page 3 of 34. The ones which are highlighted are the relevant chunks. How do we calculate this precision score of page and document? Right? So our answer was sitting in file 1, file 2, and in file 1, page 3 and page 6, and file 2, page 36. Did it cover all the right pages? What that is called as your page precision. So it covered 3, 6, and 23. So 3 is covered, 26 is not covered. Okay, only one page was correctly covered. And this is from file number 1. So correct. So 1 out of 3 pages was covered. So it is 33%. The page precision is 33%. 1 out of 3, 1 by 3. Right? Similarly, the file precision is, it covered both file 1 and file 2. So both files were covered, 2 out of 2, 100% page document precision or file precision. As you go more granular, document precision, page precision, and paragraph precision will give you good understanding of, is your RAG working good at an index level? Is it working within that index pages level? Is it working at paragraph level? If it is working till the paragraph level, it is great. If it is not working till that level, it kind of falls off. Does that make sense? So your metrics for RAG are page, paragraph. It starts with document, page, paragraph. These are the 3 levels. And don't think of these like books. These are page can be website, pages within that, and HTML index in that. In case of a vector, in case of a relational database, it will be the name of database, the table name, and the row name, row number. I have given you more metrics here. So recall precision, qualitative, is it factual, is it grounded, is it answerable or not? And then latency, output or scale, and user trust score. You can read this on your own, but let's do another 1.5 hour of session. I don't think we did complete all of this session. I don't want to breeze through this, but I hope you got value in the last 1.5 hour, right? I'll take some questions and then I'll try to cover some more content. So let's go one by one. Mohammed Diallo, you can go ahead and ask your question. Product space team, if you can help unmute the candidates. Let's just keep one question or 2 questions each from those 4 people. Anirudh, Mohammed Diallo, Neil K, and Vishal, if you have questions, just raise your hand so that it becomes easier for the team to unmute you if you have any questions. If you don't have question, that's totally fine. Yeah. Yeah. Himanshu and the team, can you help them? You
Yeah,
even
so
raise
we will
your
go first
virtual
with
hand, not your real hand.
we will go first with Mohammed Diallo, I think.
Yeah. Hemant will not be able to take your question. The criteria was only those folks who are on camera throughout the session. So apologies for that. Go ahead.
Mohammed,
Okay.
yeah.
Thank you for this great presentation. I have a short example question. Under text splitting in RAG, you said that we can upload multiple
File.
file,
Yeah.
but there is not option over there to upload. It's copy and paste in my. I don't know if I have the
No,
same.
no, this is just a
does it?
playground. This is just an example playground, which we were seeing to understand. When we actually
Okay.
create a RAG, like the one that we will do if we have a follow-up session, we will actually integrate it with your Google Drive. In Google Drive, you can upload any files. When we create an
Ah,
agent which works on RAG, we will actually help you build it with that. Yeah.
okay, great. Okay,
Yeah.
thank you.
That was just a playground to explain you the concepts, how it works.
Okay, I see. Okay, thank
Yeah.
you.
Yeah. Anirudh, if we can unmute Anirudh, please.
Yeah.
Thank you. Great session. Thank you for diving into things deeply. My question is, considering LLMs are trained on their own, whatever they're trained on, and we are giving a data set for RAG, how do we control, if I have a question, how do we control what part of the answer comes from the LLM's own training and what part of the answer comes from RAG? How do we give more weightage to RAG, or is that even a problem?
So in your system instruction, clearly tell wherever you have picked the chunk, give the chunk number and give the citation. That's fundamental principle. So that you know which part has come from RAG and which part it has own generated, right? So as soon as it generates the response, right after the response, and let me show you that. In this also, if we see, let's just run this. It will give you in box which chunk did I use, where did I use that chunk, the number. That is
Like
answering your
Wikipedia
second.
citations.
Yes, so answering your second question, how do I control how much innovative and how much? You can give it system instruction saying that keep it innovative depending on the hyperparameters of temperatures and token size that I have set for you. But wherever you are hallucinating, like the one that we saw in the second playground, right? It has clearly said where you don't know. If you don't know the answer, just say I don't know. Don't try to hallucinate.
Right.
Yeah.
Sometimes these system prompts are qualitative, as in the LLM may not follow it to the word, right? But so sometimes there are parameters that we set along with the request body. Are there any such parameters that control this particular behavior?
Yes. So in when the response comes out, you can always have another LLM model which is called the evaluator, and evaluator will sit in between and it will only allow the responses where probability or the success retrieval is greater than 85%, 90%. And we do that as part of evaluations when we cover. I don't know in your hackathon we have done that or not, but you can always have an evaluator layer which says this is very, very, very critical when we have customer support agents for Indigo Airlines or Walmart or Amazon. If I'm giving your order will arrive in 3 to 5 days and my confidence level is 70%, but it actually arrives in 10 days, your user will give you very good feedback and go like,
Yeah.
what the hell you are doing? So you can have an evaluator there which keeps a check. Yeah.
Got it. Thank you very much.
Awesome. Yeah. Thanks for your kind words. Neil K. I don't know what your exact name is. Is it Nikhil? What is the name?
Yeah, hi. My actual name is Nilesh, Nilesh.
Okay. Hi.
Thank you. I think I'm already building a RAG app. I mean, I will build two, so this is really helpful. Like I could not go deep into it. I know how to code, but I was using no code. So I mean, the parameters you've explained were helpful, and I think I use that. I have two questions. One, I think,
Then
is related
there
to
goes the validation product space. This was useful for someone who's actually working on RAG. So if you were questioning that it is useful or not, it is useful. Go ahead now, Nilesh. Yeah.
yeah. So the one question is in the slides it was mentioned that there's a hallucination measurement rate or something. There was a metric, like you were going through the metrics, right? How is that calculated, or who calculates it? Like, do we implement something?
Let's try to do a deep dive on session, follow-up session. I'll try to organize that because see, these metrics are very important. And also, I think without putting aside Hemant's question, he also wanted to understand how do you define what is the right measure? Like what is the goal? 70% is good, 80% is good. How does that happen? Right? So it is one, it is domain specific. But in case of retrievals, anything which is a greater than 70 score is good. Out of the box, the RAG providers like Google Vertex, Pinecone, they give you these metrics. Like they will give you the chunk number, like it will tell you which chunk did I refer to get this information. Now, how to convert that chunk to your document name and document paragraph ID, that you have to write certain Python code to parse it. क्योंकि आपको chunk पता है. Now from that chunk, you will need to go back and see that, okay, this was this chunk, and in this chunk, this was the paragraph. So that you will need to implement on your side. But out of box providers like Pinecone, Google Vertex, they give you the chunk number for response. This was the chunk. So that is done. How do you set the value? Ideally, I think 70 on precision and around 65 to 65, 60, 65 on recall is a good score to start off retrieval. You are on mute. You were put on mute. I think you can yeah.
So we start at 60, 65, 70, and then we move upwards so that we get more accurate.
You move upwards because you will know what type of user queries are being correctly answered with 60, 65, 80%, which are not. Jahan pe bhi, wherever you see score going lesser than 40, 45, 50%, one thing we did in Microsoft Copilot was limit those responses for users. Rather than saying we are not able to generate that, for a while, limit the RAG application of that. Tell the user I'm not able to answer this. We are upskilling to get our RAG better. And show higher value use cases to the user at the start. And improve the RAG for those use cases जहाँ पे score clearly कम आ रहा है. Hemant, I hope that answers your question as well.
Yeah, I had another question, which was the part where the LLM, so the retriever, which so is it the LLM that does the retrieval, like it sees all the chunks, all these vectors, and it then wherever it is queried, is it the LLM that looks at all these chunks and then retrieves relevant information which it thinks would help answer the question?
No, LLM does not. So you have your retriever model, or you have your retriever that was sitting in between, just to show you this. Because if your LLM is doing the retrieval part, then it has access to the data. So this retriever that we design here, like there is a retriever on top of your Vertex, there is a retriever which is top of your Pinecone, that does the retrieving and does the Pinecone. Your LLM does not do the retrieving part. Those retrieved tokens are passed as context to your prompt. So a retriever has to be configured by you. And retriever also takes care of RBAC, which is role-based access control. Again, you are on mute.
Yeah, so in the beginning you mentioned that you don't give every like file to the LLM, you give it relevant. So it is the retriever that decides.
Yes, which chunks or which tokens will go to the LLM.
Yeah, so I made that this like RAG application in ML10, and in that it was just the LLM. I think I did it a month back. So this retriever was not, I think, part of that.
So you need to configure that. That's the problem which mostly people do when they kind of see this. You re-ranker coher, which is there, which can decide the rank tokens which will go to the LLM model.
Oh, I think yeah, it was one. It was not called re-ranker. I think it was data splitting, chunking there.
Yeah. That is just for chunking and splitting of the response. Yeah.
So I need to add a retriever now, so that.
Yes, and you have to configure that retriever for top 5 tokens only.
Okay. Thank you. I think.
Awesome. Thank you so much. Hopefully we get another World Cup for the ladies today, cheering them on. thank you so much for your time. I hope you got value out of this session. It was nice interacting with you. Hopefully see you, some of you on the campus as well or in the cohorts. Thank you so much. Have a good one. Bye-bye.